Alright guys, we're going to begin a new series on natural macromolecules. Now imagine this. You and your friend are going up to a store and you see all this really cool stuff that's on display and you be go in and say, I'm going to practice my democratic right to choose the best clothes and fashion with my money in my pocket because I am the consumer and I will dictate how all money is spent, at least my money is spent, and so I am important because I am a consumer. Right? That's not how it is. No, not in chemistry or biology or ecology, yeah. So in ecology and biology and I guess a little bit of chemistry, consumers are simply organisms like us. We're a consumer and we eat stuff because we can't make stuff to make us function and work. So that's what we do. We consume other organisms so that we can get nutrients. Now, what kind of nutrients do we actually get? Well, 3 types of nutrients. First, there are carbs. Now, carbs are short for carbohydrates, which are just sugar, right? So sugars are also called saccharides, and we'll go more into sugars in later video units. And it can be like a short chain of 6 carbon atoms or a cyclic form, and this is the kind of sugar that we're most used to. And it's interesting to point out that it doesn't really matter where the OH is. Well, it kind of matters, but not for now. And so the OH, depending on where it is, will determine its chemical properties and stuff like that. Yeah. So these simple sugars are known as monosaccharides because they only got one unit. And that's it, right? But you can put a couple of them together and make a link, and these will have 2 saccharides. So it's double saccharides, so you call them disaccharides. And when you make long chains of it, you polymerize it. Now this isn't a really accurate drawing, but I'm just trying to get you to see the big picture. Then you get a polymer of sugars, carbs. You make starch, cellulose, and glycogen, stuff like that. All right. Another important nutrient that we as consumers take in are proteins. Yeah, stuff that makes this all possible. Whoa. Yeah. Oh. Anyway, yeah, proteins are basically made of 20 types of amino acids. You don't really have to know all 20 of them, but it might be kind of cool to know simple ones like alanine, glycine, stuff like that. And now it depends on who teaches you proteins. Some people will say they are polymers because of this generic formula where R is the only differentiating factor. Other people like me say they are not polymers because they are not repeating units of the same stuff. Because of the different R groups, this R group plays a very important role because the different R groups means that it has different functions and different chemical interactions with itself, and when you form long chains of it, it will fold in, bake into complex 3-dimensional shapes that is possibly not unpredictable, unlike polymers, because polymers are repeating units. But you can't really say that for proteins. You can't just line up a bunch of proteins and say, oh, you're all gonna form this and then you're all gonna behave like this. No, it's not like that, right? Because it all boils down to the DNA or RNA, in actual fact, and the codes with it. So yeah, you can take what you like out of it. You can call it a quasi protein, but I wouldn't even go down that path because it's really complicated. All right, and finally, the other natural macromolecule we take in as nutrients are fats and oils. Now, fats and oils are not polymer, they are triglycerides. What does that mean? That means it has a long hydrocarbon chain, not exactly a polymer, right? And it has this carbonyl group with this linking thingy-majiggy over here, which we will all talk about that in later video units. So there you go. We, as consumers, not only go to stores to buy like cool jeans and caps and shoes, but we take in nutrients as consumers so that we can do this or this. Whoa! All right, next time we'll talk about carbs.